My name is Alessandro.
Yes, you can do it.
Okay, so I'm going to talk about why do we still like playing games on our original C64. And as you can guess from the title, I think it's not just nostalgia. And after that, I'm going to talk briefly about a project that I've been developing for a while to address this theme of the talk. So, like I want to start, like I think everyone knows that we have a modern version of the C64 called the C64 Maxi, because there was a mini version as well. And but I used to have both. I only have the original one nowadays. And the reason why, which is surprising, is like you get the new one again for the nostalgia feeling. You want to try your games that you used to play with as a kid. But then when you play with them, there is something that doesn't really work. There's something off about those games when played on this more modern system. And so what is this big difference between games, the same game played on the original hardware versus on the modern version of it? So I think it is about latency. And latency is like the time between when we do something with our game controllers and when we get a response from the screen or the speakers. It is quite a short time interval. On modern gaming systems, it's about a tenth of a second. So it looks like it doesn't matter much, but it used to be much less with the older hardware, like, again, the Amiga, the Atari VCS was extremely fast, the Commodore 64. And latency is something that is not easy to notice consciously. So you notice that there is something off with the game, but you don't know exactly what it is. And this was exactly my experience because I started playing games on modern hardware quite recently, because I used to play games when I was young, up to my late 20s. And then I moved to London from Italy to build my career in software development. And I didn't play video games for many, many years. And more recently, I got a modern console with a few games, and they were all beautiful, but again, there was something off about them. I didn't have a lot of fun with them anymore. And I left it like that for a while because I just thought maybe I just grew out of the hobby. I'm a grown-up man now, and I don't care about this anymore. But still, I have a passion for the idea of video games. And again, I remember having a lot of fun when I was younger. And not very long ago, I had the opportunity to have a chat with a game developer called Dino Dini. I don't know if you remember him, for example, for a kickoff on the Amiga and Atari ST. It was a very very fast soccer game. It was very famous in Italy when we were young. And I showed him a little demo of a game that I had made for the iPhone. And the first question he asked me was, how high is the latency on this one? And I had no idea that latency was a big thing. I just assumed, like many other people, that it doesn't matter much. It's a short amount of time. Who cares? But then we noticed that it was about, again, in the 80 to 100 milliseconds. And he started telling me how big of a deal it is in game development and also in game design. Because, for example, if you have a high latency and you do a driving game, for example, you cannot have steep curves that come to you very quickly. Because even if you had the ability to drive the car safely through a situation like that, because of the latency in the controller, you would not be able to make it. You simply don't have the time. And so he said that it is a very big deal in modern game design as well, so much that designers have to adapt to having high latency. And apart from that, latency has another effect on us, which is when we are playing a fast-paced video game, or when we are driving, when we are playing sports, skiing, any activity that requires our full attention and requires us to be able to react quickly, it takes us into what you can call a state of flow. And when you have high latency in the controls, your brain kind of goes like, no, this is not really, it doesn't really require all of my attention. And so it gives us a kind of a state of boredom, similar to, like, for example, when we are binge watching TV. And that is something that makes games less enjoyable. So much so that nowadays, like more modern games, they focus on like the immersion is based on the story, the beauty of the environments and stuff like that. But the game itself, if you strip out all of the aesthetic beauty, is not as fun as it used to be in the past. So my idea was, after discussing this with Dino, and after he told me about the importance of having low latency, my question was, can we get the best of both worlds? So can we get a system that has modern graphics, but the responsiveness of a C64 or of an Atari VCS, and possibly something that you can make games, at least simple games, easily for it. And so I started developing a project to do that. So the problems I got was that the most powerful systems, like, for example, a high-end gaming PC, it intrinsically has high latency, and there is not much that can be done to reduce that latency, because it's exactly in the system structure. There are many layers that cause this high latency. On the other hand, there are FPGA systems that are used to emulate older hardware, like, for example, the Amiga, but even something a bit more powerful, like I think they're doing the consoles of the 90s. But FPGA systems, like you cannot program them yourself. And also, like if you want to have low latency on like something a PlayStation 4 or a PlayStation 5, you probably will find it difficult to find an FPGA that can emulate that, at least at the moment. So is it so hard to rebuild the home computer? Because when we were younger in the 80s and 90s, I think that the idea of the home computer was really, really, really a great idea, because a lot of people like us learned a lot about computers by using those systems. And they were kind of different from the computers that people used, I don't know, at work. And nowadays, on the other hand, it's all standardized, and essentially, like whether it's a gaming console or it is a personal computer or a laptop, they all share, they have a lot in common in terms of architecture. So I wanted to see if it was possible to do something close to what the old home computers were. And so I set for myself a bit of requirements. Like one of them is I want to be able to control as much as I can of the tech stack, so that I can tune everything for low latency. I didn't want to use any expensive hardware, so I started with something simple, which is a Raspberry Pi 4 in my case. And okay, having the concept of the home computer, but there are things nowadays that we want to be able to do anyway with the computer, like, for example, networking, or we want to connect USB peripherals to it. So writing everything from scratch was not an option. So I started from OpenBSD, which is a Unix system. It's very stable and secure, but it had two characteristics that were very important to me. One is that it was the only BSD that supported Wi-Fi on the Raspberry Pi 4. And the other one is that it has a license that is that is really open. Like if I had developed my project on Linux, because I'm changing the kernel heavily in order to achieve low latency, I would have to open source all of it. And instead, I'm doing essentially the same that Sony has been doing with the PlayStation, where they base their system software is a modified version of FreeBSD. Yeah, so I developed a prototype of this low latency system, and in parallel with it, I developed an architecture that allows for low latency, but on modern systems like Unix or potentially even Windows. One key aspect of this architecture is that one has to be able to control the whole stack in order to optimize for latency. So yeah, I'm based on the Raspberry Pi 4 at the moment. not the Raspberry Pi 5, because the Raspberry Pi 5, for example, introduced a chip called the RP1, which connects, for example, the GPIO through the PCI bus to the system on chip. And that increases latency by a lot. So I didn't want to use that as a baseline system. So I'm still in the previous generation, but at some point I will think about moving to something more powerful, which could be even like, for example, the PC architecture. I do have a port of Vice for my prototype, which is very, very, very important to me, because it allows me to show, like, people who like playing retro games, they tend to think that emulators are bad and FPGA is the only way to go. And instead, this port that I have proves that you can have software emulators that behave really, really, really well. And the one thing that I'm happy about is that everyone I showed my prototype and who has played with it for a while, they all said, yes, this is how I remember it exactly. This is fun. It's not like, for example, other products that have tried to give people the only that feeling of nostalgia, but technically what they do doesn't really satisfy the players. Yeah, so this is pretty much what I wanted to discuss. If there are any questions, please ask them. Otherwise, I left a couple of links. One of them is my Facebook page, which is simply called No Input Lag as a single word, which is my preferred way of contact. If you want to have a look and maybe follow it, it would help. And the other one is my LinkedIn address. If you want to help or develop a game for this kind of new system, please get in touch, because I am at the stage where I'm looking for somebody to develop like a killer app for it. So a game that is that has like more modern graphics, but at the same time low latency. It's very fast, like I don't know, a space shooter, or like in the old days, but with more modern features. So yeah, that's pretty much it. If there are any questions, go on.
Many thanks, Alessandro. I don't see questions there. Maybe I will start shooting one, because you mentioned something about the Raspberry Pi 4, Raspberry Pi 4. You said, yeah, for the time being, it's okay, but I will build I will need something more powerful. Is that because you're targeting also other type of systems, like you mentioned the PlayStation, or is it just to run Commodore 64 games on the emulator? Because I think Raspberry Pi 4 should be good enough, I would say, to run. I mean, there is enough power and resource capabilities.
Yeah, I mean, so my aim is actually more general than the Commodore 64, because so the Commodore 64 on the Raspberry Pi 4, it runs quite well, and it does have some higher latency compared to the original Commodore 64. If you use like a typical Linux distribution, Linux-based, or even there is they call it a bare metal emulator, but even that one has a high latency. So latency in gaming is a problem like that happens pretty much everywhere nowadays, apart from FPGA. So the idea is I am starting with like 8-bit consoles on the Raspberry Pi 4, but I would like to get to the point where all games can be played with low latency. So at point, I would like to be able to have like my architecture ported on a PC with like a high-end graphics card and stuff like that, and play modern games with low latency.
Okay, but that's then for modern games. But I would say then if you would be targeting only the Commodore 64, then the emulator on the Raspberry Pi with this modified version of OpenBSD would be largely enough, right? If you would like to make it like commercial software now or something. Or...
Yeah, so for the Commodore 64, it is enough. And probably even for other systems. I'm actually looking at having a PS1, PlayStation 1 emulator that runs well on this one. I need to do much work on that, but it's not ready yet. But the Raspberry Pi 4 is capable of emulating quite a lot of systems. I think it struggles with Nintendo 64 or PlayStation 2. Yes, fair enough. But like systems that were earlier than that probably will work.
Okay. I'm reading the comments here. I see a good let's say point from Chris, who says, "Yeah, shame that that Pi 5 won't work because they, yeah, I guess they continue to develop based on the Pi 5 and instead of the 4, even though they still sell the 3 and the 2 and even the 0. So, okay, BMC64 is interesting.
Yeah, but the 5, I think it was. I think that Raspberry Pi has kind of split between the low end, which is the Raspberry Pi Pico, and the high end, which is the Raspberry Pi. And they are actually adding a lot of features to the main one. But yeah, adding more features can mean increasing the latency. Like in this case, I think that the people at PyStorm, they have kind of the same problem, that they cannot, they struggle with releasing a PyStorm based on the Pi 5 for this very same reason.
Okay, interesting. I don't know if there are any questions from the attendees. Just unmute yourself.
I have one question, Alessandro. Have you tested with MAME to the emulation of arcade games?
Yes, I've done. So what I've done is a simple front end for libretro. Do you know?
Yeah.
Yes. So I have run a couple of games with MAME as well.
Okay.
I think I tried the one with the motorbike. It was called Traveling USA, something like that. And yeah.
Yeah, but because on that I have experienced the same thing, that you something is off or missing, or when you run the emulation on your ordinary PC or Raspberry Pi. Interesting, interesting topic and reflection.
Yeah, the reason is I think it's exactly latency. Then, of course, people talk about, for example, CRT shaders because they make the graphics look better because it was designed for. But I do have, for example, on my system, I do have a CRT shader, and it increases the visuals of it. But what makes a huge difference for people is the latency, and also I don't know if you like in modern games it can happen, for example, that while it's scrolling the image, the screen, it stops for a while and then it restarts. I don't know if you.
Yeah.
So that is another thing connected to these kind of issues that I solved with my own software architecture.
Interesting. Thank you very much.
You're welcome.
Thank you indeed. Maybe just one, I don't know if it's the last question, but at least from my side, because now you mentioned what you're doing, what is your intention, what is the current level. But now I'm a bit hungry for the next steps. So can you elaborate a little bit on what are the next steps? What is the timeline? By when do you expect to have like a version that would be either distributed in what type of
Yes.
Tell us about the future then.
Okay, so at the moment I am trying, like at this very moment I'm back in Italy, but I do live in the UK, and I'm trying to get a government grant in order to start to like finalize this into a product and start selling it and patenting the architecture. So this will be from if they give me the grant, it will be from October to March. I will have that window to finalize the product. But one thing that I was thinking was I'm working on like a simplified system that still has the low latency, but it doesn't have the things that I want to patent. So I may be able to sell some prototypes of that like sooner, like in 2 or 3 months. Maybe with that one, I will include like the Commodore 64 emulator, and then a way for people to compile their own code that they write in C. There will be like a library to access it. But yes, if you are hungry for more, follow the page, and maybe in a I don't know, in a month or so, send me a message, because I will like if I can do it quickly enough, I'm happy to start like talking to people, because that is my next stage. And I would like to do this as soon as possible, actually.
I will follow the page, definitely. I missed one question actually from Camila here. She says it's very interesting, but is the bad feeling only response time or also frame rate?
Okay, so frame rate, like for example, you can have a very high frame rate nowadays on high-end PCs. Like I think they have 360 or something like that, possibly even more. The thing is, frame rate, like of course, if you have a very slow frame rate, it will not feel responsive. But if you have a very high frame rate, but still high latency, it doesn't make much of a difference in terms of bad feeling. It's like, I mean, if in real life you drive your car, you turn the turning wheel, and the car starts turning after a second, it's probably too much, and there's nothing about the frame rate there. It is mostly about the response time. Of course, like if you have I don't know, 10 frames per second, you have you have a tenth of a second of lag anyway. But if your game runs on 60 hertz, or in the PAL version of the Commodore 64, if it runs on 50 hertz, like on the real hardware, you get an immediate response and you don't feel any latency. On a much more powerful system nowadays, like your game, it will always run at 50 or 60 frames per second because it's so fast, but you will feel the latency. So I would say, of course, the frame rate, it has to be at a certain level, but the response time, given a good enough frame rate, the response time is the most important.
Thank you.
You're welcome.
Many thanks, Alessandro. I don't see any more questions.
You're welcome.
I will stop the recording now.
Yeah.